All right, so now we get to talk about the chain rule. And the chain rule works very similarly to how the chain rule would work in normal one variable calculus. Uh, you, we've been using it actually in previous videos and other problems. Uh, Here it's a little tricky because generally you're given both things. So in a two variable situation, so notation dz dt, where z is our function. We take the derivative of the function, the whole function z with respect to x, and multiply it by our derivative of x with respect to t. And similarly, we pair up the y components. So the derivative of the function with respect to y multiplied by what the derivative of y is with respect to t. And there's a generalized form here where we're pairing up each individual one. So the first variable x1, the second variable x2, all the way to x. They're using m. So problem number 215 has three variables, has an x, y, and a z. And let's see what we can do. We're looking for dw dt. So we have three different pieces that we want pairs for. So dz dx is that function with respect to x. We treat the y cosine z as a constant, and then derivative of x is just 1, so that would be y cosine z. That's the derivative of z with respect to x. And then dx dt would equal, well, x equals t, so the derivative of t would be 1. So that product will give us y cosine z times 1. Our second one, we want I guess this is a w. I apologize, because we have a z. It's dw, this is dw, dy, or again, you can just use f of x, f of y, f of z, that's fine. Anyway, with respect to y, it's going to look very close to that. Derivative of y is just 1. The x cosine z, excuse me, are just constants. Treat them as a constant. And similarly, dy dt. Now, in this case, our y is t squared. Derivative of t squared is 2t. And our third piece will be dw dz. So the xy would be the constant form, and the derivative of cosine of z will be negative sine of z. And you can pull the negative out. Well, I'll do that when I multiply. And finally, dz dt. All right, well, this one is different. So the derivative of arc sine of t would be 1 over root 1 squared minus t squared. And so now what we have, dw dt will equal y cosine of z times 1. That's our first product, this one and this one. Our second product is x cosine of z times 2t. That's this one and this one. And finally, plus, we can just do this as a negative. So minus, we've got a fraction over here, so I'm just going to say minus x, y, sine of z all over root 1 minus t squared. And again, you can pull out the 2 and the 1. So one more step of cleaning would be fine. But let's just finish. So this is y cosine of z plus 2t x cosine of z, and then minus what we have there, x, y sine z over roots 1 minus t squared.